For the special meeting of the Solvang City Council, Monday, April 15th, 6:30 p.m. Can we get a roll call?
Councilmember Clark.
Here.
Dearness.
Here.
Johnson.
Here.
Waite. Here. Mayor Toussaint.
Here. Daniel, want to lead us in the pledge?
Sure. Everyone please stand. Right hand over your heart. I pledge
allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All right, on to the regular agenda. Lisa, can I get a title readout?
Wastewater treatment plant upgrade alternatives. Receive presentation on proposed wastewater treatment plant deficiencies, improvement needs, and upgrade alternatives, and provide staff with further direction as deemed appropriate.
Perfect. I believe we're receiving a presentation and staff report.
Yes.
Matt Vanderlyn.
Yes, thank you. Good evening, Mayor Toussaint and council members. Matt Vanderlyn, and your Public Works Director and City Engineer. And so we have with me today our consultant, Andy Comer with Pace Engineering, and also some of our wastewater staff. So you may know Nathan Giacinto is our wastewater division supervisor and the wastewater treatment plant superintendent. And then with him is some of his staff, but particularly Paul Matsoukas is the lead operator at the wastewater treatment plant. So they're here. So we got everybody here as best as possible to answer any questions you have at the end of the presentation. But before we launch into the presentation, I did want to give a few introductory comments. And so I just wanted to mention and just clarify that the purpose of the presentation this evening is to help continue to educate our community members about the need for the issues and problems that we're experiencing at the wastewater treatment plant, the need for improvements and the various upgrade alternatives. And also, since our last presentation of this in September, we have 3 new council members, so we want to continue to help educate the council on all of these issues, and including discussing the alternatives. And so as you'll note in the staff report, we are requesting the 2 actions from the City Council. One is that we're requesting approval to proceed with a capacity of the plant at 1.5 MGD. So in the studies and other discussions we've had, we talked about various different treatment plant capacities, but we're recommending to proceed with the 1.5, and we're seeking your approval on that. In addition, we are requesting the City Council approval to move ahead with the approximate 2.23 acre land acquisition. And so just by way of reminder, the presentation we're going to be giving this evening is essentially the same presentation that was given in September. So of course, Mayor Toussaint and Councilmember Waite were here to see that presentation, but a few things have occurred during that time. So the current presentation has some updates from September. So some updates as compared to that September presentation, and then I just wanted to remind everyone, at the last City Council meeting covering this, so back in September, the City Council was not ready to make a decision on which alternative, and so the City Council asked the staff to go back and research 4 items which are covered in the staff report. And those 4 items was number 1, to talk to the San Ynez Community Services District to confirm if they still wanted additional capacity. So we've done that, and as outlined in the report, they have indicated they do not need additional capacity. They want to just stick with the 0.3 MGD capacity that they have. The second thing that the City Council asked us back in September was to make further contact with the Los Olivos Community Services District to confirm if they wanted additional or wanted capacity in the Solvang plant. And we've made multiple contacts with them, and they have basically said they would like us to keep the door open for them, but they're not going to be able to make a decision for a year or more on whether or not they're going to build their own package plant or want to send the wastewater down here to Solvang. However, the conversations that we had most recently with them, they are leaning towards a small sewer collection system and small packaged plant there in Los Olivos. So that's where that stands. So we've researched both of those. The third item the City Council asked us to research is to have conversations with the Alisal Ranch to confirm that they'd be willing to sell us some additional land. So we've had those conversations with them. They said they would be willing to sell us some additional land, and so we're reporting that back in the staff report and with this presentation. And the fourth item that the City Council asked us to research and investigate was the impact of the cost of the different alternatives on a typical customer's monthly sewer bill or sewer rate. And so we're just about wrapped up with that. We've done quite a bit of analysis. We're going to have to kind of review that a little bit further, but we're planning to come back to the City Council in about a month with all that financial information. So this evening we're not intending to go into that in any detail. This evening we want to cover, again, review the needs or the problems that the plant's having, the need for the various improvements, and the various upgrade alternatives. And I did also want to mention that making a decision on the capacity of the plant tonight, and that the staff would move forward with, and making a decision directing staff to acquire the land will not limit the City Council's ability to select between the three alternatives. And it'll also help us be in the best position for pursuing any further grant funding if we have the land acquired and everything. So so with that, I think we'll turn it over to Andy Comer with PACE, and let me get the presentation.
Thank you. Hi, good evening. My name is Andy Comer. I'm a water and wastewater engineer, professional engineer in California, and next year I'll be, I've done this for 20 years in a row now. I love water and wastewater. It's my big passion, and I love the opportunity to work with you guys for about 2.5 years now. We've developed this master plan, and it's a thick document, got a lot of content in it, but at the end of the day, there's 3 really good, solid options, and I think you wouldn't go wrong if you chose 1, 2, or 3. But in the September presentation, you know, we sort of lean one way or another, and I want to just kind of take a fresh look. Let's take a step back, start from the beginning, go through it with the new council members. Looking forward to meeting everybody here tonight, and sort of give you what the options are.
Could someone hit the lights?
So at any time, interrupt me during this. It's supposed to be a little back and forth. So at the end of the day, we want the new City of Solvang upgrade of their wastewater treatment plant to maximize the long-term value. Let's get the most bang for our buck and set us up for the long term here. So as I mentioned, I've been doing wastewater treatment for 20 years now, and a lot of people, if you don't remember your high school tour to the wastewater treatment plant, you have to do 3 things. Number 1, you have to remove the solids in the water that you can see. There's a lot of solids that come down the pipe, and you've got to remove those. So on the left-hand side of the page, you've got screens, you've got grit equipment, you've got things to remove the stuff you can see. The second thing that's in wastewater is the stuff you can't see. It's dissolved. It's the dissolved sugars and fats and oils and nitrogen and phosphorus and all these things. And in the middle of the page, you have to set up beneficial bacteria with air to eat all the things you can't see. And you clarify out those bugs, you get rid of those bugs, and you make your way to the third thing, which is you have to disinfect the water to make it safe. You're going to get rid of the bacteria, the viruses, and the protozoa so that if that water ever comes in contact with human health again, it's safe. And obviously, if you want to use the water again, recycle water, for example, which we talked about in September, you've got to store it and pump it to the distribution system, whether that's golf courses, farms, fields, etc. So what does your existing facility have? Raw wastewater comes in on the left-hand side. You have screening. You have grit removal, so you get rid of the solids that you can see. And then in the middle, you have what's called sequencing batch reactors, or an SBR for short. It's an acronym. We have a lot of acronyms in this industry. And it's kind of like baking cookies. In the oven, you do something for 5 minutes, and then you do something else for 5 minutes, you do something else for 5 minutes. Well, in an SBR, that's what you do. The wastewater comes in, you hold it like a batch, and you mix it for a while, you aerate it for a while, you settle it for a while, and you pull off the clean liquid. And then you do it again. You make another batch. So it's a batch system. And so then from there, instead of filtering and disinfecting your water, you discharge it directly to percolation basins on the edge of the Santa Ynez River, and it flows into the underflow of the river and goes downstream to Buellton. That's what you have now. Yes, we did. So then here's a plan view of the system, and it's a long bowling alley. On the left-hand side of the page is way up high, and then it kind of slopes down towards the Santa Ynez River on the right. So wastewater comes in, and it's screened out in number 1. You take out the stuff you can see, and then it goes into those 3 rectangles in the center of the page. Those are the 3 batch reactors, or the 3 ovens that you're making your cookies, for example. And in there, you're doing those different sequences, and then out of there, the water goes straight to the percolation basins. Next slide. So then what did we look at to improve that? Number 1, we looked at leaving your SBR system and adding an equalization tank upstream to sort of make it work more efficiently. So it sort of supercharge what you already have. Option 2 was to actually put on circular clarifiers to expand the treatment capacity and clarify the water better before it goes to the percolation basins. And option 3 is to add a high-tech modern membrane, a physical separation system, which then you can get triple the amount of capacity in the same box and make very, very good quality water. And you could do whatever you want with that. So in here is sort of that membrane, that third approach. So as you can see on the left, the stuff you can see, and we'll add additional screening if we go with this option. Then in the middle there, the stuff you can't see, we do it just like we were doing before, but instead of in the batch system, and assuming we want to go with option 3, you would continuously treat that water. And then in step 4, you would reject it with this high-tech membrane, and then you could disinfect it, you could store it, you could send it to the percolation basin that you already do at a much higher quality, so that when it goes into the ground, you could later pull it out and do something with it, such as treat it again and possibly drink it. So there's options on the table. So what would this new facility look like if you did go with option 3? As you can see, it sort of looks like what it did before on the left-hand side, but on the right-hand side in those squares, you would have these new membranes, you'd have a new equipment building, and you would have downstream pumping and storage and other project elements which haven't quite been figured out yet. So why are we here today? We want to focus on 3 key drivers. Number 1, we want to look at converting the existing process. Number 2, we want to achieve higher capacity. And number 3, we want to look at either recycle water. Recycle water could mean sending it to a golf course, Alisal Ranch, or it could also mean possibly recycling it through the ground to become potable water down the road. And so number 1, we looked at the existing problems. There's a lot higher waste in each drop of water that comes in compared to the original design. Low flow fixtures, low flow toilets, low flow washing machines. It's making the amount of water go down, but there's actually a lot more pollution in that water. So therefore, your old capacity, which was 1.5 million gallons per day in 1993, we now think it's 0.9 million gallons per day. Number 2, there's no filtration on the downstream end, so there's solids that go to the percolation basin. There's a polishing basin upstream of the percolation basin. It's part of the percolation system. It hasn't been dredged out since 1982. So if you go out there today, the solids are accumulating. It's going to be a cost that the city has to incur. And once we clean those basins, it'll then occur again in another 20 years. We can avoid that operations cost if we put a filter on the system. And thirdly, there's going to be new nitrogen standards. So when this plant was originally conceived, there wasn't the same scrutiny on the water quality that there will be shortly. Number 2, as I mentioned, there's these 3 options on how to convert the plant. Number 3, where are we at today? We're at 0.75 million gallons per day in 24 hours, and the capacity of the plant's 0.9. So we're greater than what we call as engineers the 80% rule. Once you get to about 80% of the treatment capacity, you better start looking at the expansion, and we're pretty much there now. If these operators were to lose a basin for some reason, let's say they had a mechanical failure or they had to take a basin out of service, their capacity would be 0.6. They'd actually be over on their capacity. So we need to look at some more capacity. Fourthly, what do we do with the water once it's been treated? Do we want to recycle the water? And then lastly, let's come up with a game plan. So the existing system needs upgrades, and it's close to the solids and nitrogen capacity limit. So on the left-hand side of the page there, that's the basin where you actually have beneficial bacteria that remove the stuff you can't see. It's called an aerated sludge or activated sludge basin. And in that basin, you provide air. Well, the blowers that are out there are at the end of their useful life, and they're also oversized, and they're having problems running on their curve. Secondly, there are some bubbles that you see in the middle of the page. That aeration system is supposed to be very homogeneous. It's supposed to be, thank you, very homogeneous. And instead, as you can see there, you've got big bubbles in the middle and you've got nothing on the outside. So there's upgrades to the blowers, there's upgrades to the diffusers, there's things you have to do no matter what you decide to do. And on the right-hand side of the page is the polishing basin, and that's what I mentioned before is filling full of solids that we should do something about. This slide shows you the original design ammonia, which was about 25 milligrams per liter. And instead, because of the low flow fixtures, we're getting close to 50 milligrams per liter. So we're getting double the amount of pollution with respect to nitrogen in each drop of water coming down the sewer. That means more air, more bugs, more treatments required. So in addition to the process conversions, as Matt mentioned, there's just basic things that we need to do. We need to do site security. We need an admin building. We need a parking lot. We need to have a place for people to check in when they enter the site on the left-hand side of the page. There's paving that's required. There's sludge processing that's required. So there's ancillary things that we have to do regardless of which option we choose. And so I think I've sort of beat this to death already, but option 1 is the turbocharging what you have. It's keeping the SBRs. So on the left-hand side of the page, the white part, that's option 1A. That's assuming you don't want to do recycled water and you don't want to filter and disinfect and you want to keep doing what you're doing. That's 1A. If you bolt on the pink portion or the purple portion on the right-hand side, that becomes option 1B. So 1A is no recycled water and 1B is recycled water. Option 2, clarifiers, same exact thing. On the left-hand side, 2A is just basically making water so that it can go into the percolation basins. And if you bolt on the filters and the disinfection on the right-hand side in the purple, that becomes option 2B. So far there's 4 options, 1A, 1B, 2A, 2B, and the 5th option is this membrane process. And that process, you don't have a choice. You have to do purple. There is no white. Once you put the membrane on, you've created recycled water. So there's no way to go kind of halfway. You're all the way done with this option 3. So we looked at the cost of these different options. It's on the next slide. But I just want to mention kind of where does the capital cost lie on this project? Well, there's general site construction. That's about 10%. But the secondary process, that's like the process conversion. Whether you do options 1, 2, or 3, it's around 1/3 of the project. And obviously on the very bottom there, the general conditions for the contractor's labor and the soft costs for engineering, permitting, services during construction, that's also 1/3. So we have to kind of think about if we're going to do a project and we're going to mobilize and we're going to design it and everything else, it sort of needs to stand the test of time. It needs to last a long time. Thanks, Matt. And then before I get into the costs for how much the capital and the operations cost is, I do want to kind of take a divergence here for a second and mention that we looked long and hard at trying to generate some revenue for recycled water. So this map shows you sort of all the different areas that you could apply recycled water to. And obviously what we came to the conclusion was that the Alisal golf courses was the best place. Shortest pipeline, put it right into their golf course lake. They could pull it out, they could use it. They were interested in taking the recycled water. But there's really no way to force the market. There's no way to force them to pay more than they pay now, which is only about $100 to $150 an acre foot. Other areas of Southern California, obviously they charge $1,000 an acre foot for recycled water. But there's rules and laws in place that force people to sort of take this water because of penalties and assessments. That's not set up here. So we could recycle the water to Alisal Golf Course and sell it for maybe $150,000 a year if he's paying the same thing that he's paying today for his groundwater costs. But beyond that, there's no really other good recycled water opportunity in the city. So this is a slide here that might not be relevant, but if you did want to go to Alisal, it's pretty economical. There's a 16-inch diameter pipe, a pump station, a recycled water tank upgrade. It's very easy for the city to get the water over to Alisal golf courses. The disadvantage with doing that now is the following. You have the opportunity of you currently put water into percolation basins and it flows into the underflow of the San Ynez River. If we stopped doing that, then that potential resource downstream, the potential for someday going downstream of the treatment plant and extracting water for potable purposes might be diminished. So it's a big decision we have to think about, whether it's worth that $150,000 a year and setting up some other recycled water opportunities, or do we either keep what we're doing or make it even better, put it in the ground, and hopefully pick up an opportunity downstream.
So I just wanted to add, Andy mentioned that this slide may not be totally relevant at this point. So, of course, when we first completed the study, we were looking at providing the possibility of providing recycled water to the Alisal Ranch. But in our conversations with them, they indicated, well, it only makes sense for the city to spend the money to distribute the water to them if that will offset current potable demands and make that potable water available to the city. So we asked them, hey, if we provided you with recycled water at a reasonable cost, would you reduce your pumping from your river wells and allow it to flow by and let Solvang pump it out, because we're giving you recycled water, so you don't need that water for your golf courses. And they indicated that they'd basically be happy to take the recycled water from us, but they would not cut back their pumping from their river wells. So they would find other land on the Alisal Ranch that they could irrigate and use for crop production or hay or whatever. So at this point, that benefit of providing the water, the recycled water, doesn't exist at this point in time. So
Thank you for reminding me of that point.
What about repairing the rights downstream? Because you're right, we can pick it up downstream if we have the rights to it.
Yeah, I thought we didn't have any rights downstream as far as doing that.
well, that's a good question. So we're right in the middle of the process of trying to resolve. Well, okay, let me take a step back. So because of all the water supply issues the city has had in the past, when we did our water master plan several years ago, the key project in that was to drill additional wells along the river. And Alisal Ranch and ID1 don't want us to drill wells upstream of the bridge because that's where they have all their wells. So we would have to drill these new river wells downstream. So with that in mind, we submitted a petition to the State Water Resources Control Board to amend our permit. The state views riparian and river water rights totally different from groundwater upland rights. We don't need a permit from the state to drill a well and pump the upland, but along the river we do. So we submitted this petition to the state to modify our reach of diversion. So right now the reach of diversion is basically from well 3 upstream for about, I think, 9,000 feet. And so we asked them to allow us to extend our reach of diversion downstream, so we could add wells downstream and pump along there. And Alisal Ranch and ID1 submitted protests to our petition for an amendment. And basically, they want the city to agree to various concessions to withdraw their protest to sort of secure their ability to pump above the bridge, upstream from the bridge, without interference from Solvang. So, for example, one of the things they want to see is our well 7A is right in between the ID1 wells and the Alisal Ranch wells. They want us to get rid of well 7A. And there's a few other things, but so we're in the process. It's been a lengthy process going back and forth, and so we're actually we had a meeting, I guess it was about a week and a half ago, and we're hoping we're really close to an agreement. So, but even being close, it's probably going to be a few months still. It's like, anyway, the attorneys, spend their time editing every little thing. But anyway, so that's where we're at. So if we do reach an agreement with Alisal and ID1 and they withdraw their protest, then the state board can schedule a hearing and hopefully approve our modified reach of diversion. Now, Councilmember DeJarnis brought up a good question. Any property owner that has land along there, along the river, has riparian rights, but they have to demonstrate to the state that they're able to put that to beneficial use. So if we put future wells just a little bit downstream of the percolation ponds, but on this side, the recycled water could percolate down, mingle with the river underflow, and we could pull it out downstream. Now that project with piping and new wells, that's a whole big project of its own, obviously. And but there is that potential, and Andy was kind of alluding to that. But of course we would have to get easements and so forth. And but for most of those parcels downstream, they're not nearly as big as the Alisal Ranch. They're 100 acres, 300-400 acres, some of them, but they're not these huge ranches. And we could also, if the ideal location would be in the Buell Flat area. So basically, it's just one property owner, and we would be able to extract it before it went, down any further. But again, that's another whole big project on its own. But anyway, so I wanted to just clarify that. Do you have any other question about that specifically, or?
Would it be better to table this? I mean, it's a complicated issue.
Chris, your microphone.
Sorry, I thought I was loud enough. Obviously, this is a complicated issue. Would it be better to talk about this in a workshop setting? Because the combination of wastewater and water seem to go hand in hand here. And then you have to bring in legal issues. And I don't want to interrupt the flow of your discussion. Unfortunately, I can't help myself. This is an important question, and I had to ask it. So I hope I haven't derailed your conversation.
I would say no, because as you're aware, and probably and the staff are painfully aware, that so many things take so much time, and so if you try to get every little piece perfectly in a row, well, first of all, it's by the time you get the last piece, things have changed, and so the first piece is out of line. You
Well, that's what I'm
just
talking
can't
about.
get every little thing perfectly
These
in place.
types of conversations also have to take into consideration time, as you're pointing out, economic development as well. Right now, there's no real demand for it, as you were pointing out, but at the same time, 10 years from now, it could be a very different story, right?
Well, I'm just, we're not suggesting we proceed with river wells downstream or any of that for a long time. I'm just pointing out that's a potential possible future benefit of alternative 3 and producing, recycled water, quality wastewater. So yeah,
That's the whole
I'm sorry, I
question.
didn't mean to get go on on a tangent.
But I don't think it's a
That's,
tangent, Matt. I mean, I think it is relevant to your decision here today to a certain extent,
correct.
to have a little bit of knowledge
Right.
about that river
You
opportunity.
can't make a choice on option 3 if you don't bring in this discussion. That's the challenge.
Well, I think the main thing is just the feasibility of, when we talk about recycled water and there's, you go the MBR route and you have possible direct reuse, but then the other method would be like what you're talking about, which is letting it percolate back into the river and then pulling it back up. And I feel like probably what the question that people are coming up with is what's the feasibility of actually doing that between, easements, cost, putting a new well in. If you look at the MBR here and you might say, okay, it's a few million more and you have it right there at the source. We have direct control over it. But the second you put it down the river and then you're trying to pick it up later, the cost in doing that could make anyone here go, oh, well, we would never, ever even consider doing that because the cost just doesn't make any sense.
Sure, and there's a lot of unknowns.
Once I hear easements, I hear property owners wanting money. I hear,
Yeah,
all
exactly.
kinds of
Yeah,
things. And
yeah.
just even us trying to get new river wells down the river. I mean, how long have we been pursuing that
Yeah,
to
exactly.
no end? So
Right.
if we want recycled water and you want it anytime, in the near future, then I don't think you want to put it down the river and try to pick it up later because we could be here 30 years from now still, chewing away at it.
You did, Mayor Toussaint, you also brought up a good point also. In a few years, we do expect the state regulations for direct potable reuse to be out. Those regulations haven't been finalized yet, but that's also an option to add the last step of additional filtration and disinfection and go to direct potable reuse. And we already have the piping and everything in place because you're just basically putting into the water system.
And to me, that would just seem it just seems common sense, just seems that that'd be far more feasible because if you're
Right.
talking about percolating ponds to then send it down the river to pick it up somewhere else, you got the cost of the pumping, new wells, and then you still have the cost of delivery to get it wherever you want it to go. Now you're probably even further away,
Correct.
looking at some of
Yeah.
these pictures
Yeah.
here, you're probably even further away from your source. Now the cost of the infrastructure to get back to that source makes the whole thing completely infeasible. So
So
as
you're-
far as I'm concerned, a quick evaluation of that might throw that whole concept, right out of the picture.
Yeah. No, you're exactly
I just
correct.
want to clarify one thing, and that is that I agree that the potable regulations are almost there and they're doing it in certain areas. Those projects all use reverse osmosis, and unfortunately, you probably don't have that option here because reverse osmosis has a waste stream that we'd have to put in the ocean, which is not really feasible. There are projects around the United States that use a different process, but that's not really approved in California yet. So putting it in the ground and having credits for being in the ground for a period of time would open up that opportunity for you. And I think the biggest question, at least in my mind, is, how reliable is that underflow supply long term? And so I can't answer that question.
And I think that's what brings us back to the original reason of why it seemed to make only really pencil out if they're going to do some form of a trade deal with Alisol.
Right.
Well, ideally, I would love to see what you were describing, where we, with the state regulations coming downstream, down the road, where we can go ahead and turn it into potable water. Is there a way, and this is really out in left field, I'm sorry, is there a way to pipe it over to the area, the Alamo Pintado Delta, if you want to call it that before it hits the river, and basically drop it there and let it settle and come through?
Yeah, I mean, we physically could do that, put in piping and pump stations and stuff.
And then
That, of
the
course.
soil would filter it out, right? And by the time it gets to the river, would that work?
You generally need it, if I could help Matt, is you generally need, up to 6 months of travel time, at least 3 months of travel time. So it probably would not help you too much.
What if there were percolation ponds disguised as a city lake?
And once again, I mean, it's hard to imagine when you're flowing 1 million gallons a day, how much volume you need. You need a lot of volume, and it'd have to be generally in the ground. These percolation basins would have to be massive in order to get, imagine, 3 months or 4 months of time to come through. So
That's fascinating. I love this topic.
yeah, it is fun. It's fun to think about, but there's no real clear-cut great options here. If you had an off-taker for the recycled water, if Alisal could then not pump as much out of the river, those are good, clean options, but they don't exist yet. So that's why you guys are left with the tough decision.
So I'll let Andy finish and then we'll
Okay.
come back.
Next
to more
slide.
questions.
Just no more food analogies.
You got it. So then, I guess I need to stay on the mic. I wish I had a laser pointer, but here's a cost of CapEx. Left-hand side is in millions of dollars, and then on the bottom axis, you've got option 1, SBRs, option 2, clarifiers, and option 3, MBR. In the black bar, that's the 1A and the 2A, which is no recycled water. Thank you. Beautiful. Thank you. Oh, it's just a little bit weak. So anyway, this slide assumes 1.5 million gallons a day. So I guess we sort of dropped that whole portion of the topic. But when we originally did the study, we looked at two different sizes of facility, a 1.5 million gallons per day and a 2 million gallons per day. We felt like the 2 million gallons per day would be required if Los Alisos came in, if Santa Ynez wanted some extra capacity, and we had a lot of growth. If we didn't have as much growth and those other two entities weren't as interested, then the 1.5 might be, or should be, the recommended size of the facility. So this chart right here shows you on the left-hand side, if you turbocharge what you have in SBRs, the least capital cost is about $8 million to sort of keep doing what you're doing. No recycling, upgrade the facility. You could turn the SBRs into recycled water, and that'd be around $14 million. For the clarifier option, you could put in clarifiers, and it'll actually operate better. It'll be lower operations costs, but a higher capital cost, around $10 million. Close to 16 to turn that into recycled water. And as I mentioned before, the MBR option immediately gives you, thank you, immediately gives you recycled water. So if you look at recycled water at 1.5 million gallons a day, they're almost the same. If you don't do recycled water, these two black bars are actually almost the same life cycle cost. Option 2 is not expandable into option 3 in the future. Option 1 is somewhat expandable into option 3 in the future. You would lose some of the infrastructure that you put in, but it's somewhat convertible. If you built a 2 MGD facility, the MBR would be more attractive because this bar right here essentially is 2 million gallons a day. So I'm sorry for being confusing. This is not an apples to apples comparison. On the right-hand side here, this is 2 million gallons a day of capacity because once you convert the process, you immediately get 2 million gallons a day. In the middle here, this is a 1.7 MGD upgrade, because as soon as you convert the process, you get 1.7. And this one, turbocharging what you have, it just barely gets you 1.5. Now remember, that's with all basins in service. So if for some reason you lost one or you had to take one down for maintenance, these capacities would then go down to 2/3 of what I just presented. So this would be 1, this would be 1.1 or 1.2, and this would be 1.4. Okay?
Why did we drop it from 2 to 1.5? I remember I was here for your initial
We were
discussion.
pitching the 2 until we got the 2 pieces of information. Piece of information number 1 was Santa Ynez wrote us a letter, said they're not interested in going above and beyond their 0.3. Piece of information number 2 is that Los Olivos is headed towards their own facility. Which, on a side note, generally speaking, the state of California encourages you to regionalize. And there might be some pushback on that idea. I've had some personal experience with that.
But generally for the MBR plant, it was like a marginal cost difference between a 1.5.
Exactly.
And it was like $500,000 or something like that.
Not even.
Not, okay.
So that cost right there is pretty much what it is for 2 million gallons a day.
Got it.
And that's in this report, and it might be in the staff report.
Yeah, I was just going to add, so the basins that we have right now, those SBR basins that are there right now, we don't have to build any additional basins for to allow for up to 2.0 MGD with the membranes.
Got it. So you could easily bring a 1.5 to 2.0 with the MBR.
That's right.
For a
Right.
marginal cost.
That's right.
Basins are adequate for that.
And the downside risk is if one of the basins goes offline, we might fall below capacity or what we need to be at.
If you're over here, you're going to have a 1.5 million gallon plant with 3 basins. So if you lost a basin, you'd be at 1.0.
And
You're currently at 0.75. So you've got a little bit of
a
buffer.
little wiggle room.
Little
How
bit.
long would that be offline if it went off?
A day or two.
Oh, it's not that
Yeah.
serious then.
But it is somewhat serious. You don't have a lot of extra storage in this facility. A lot of facilities have tanks laying around. And this one, we're talking about building an upstream equalization tank, but that's not big enough to really handle.
What I'm suggesting is, from what I'm hearing, you could get it back online within a week, right?
Yes.
Okay. Yes, it is a problem, but it's not insurmountable.
Until you get, let's just say, for example, Los Olivos was interested, or you built a bunch of hotels. Yeah,
Right.
you'd be right up against it here in potentially
And
10
actually, I'm
years.
glad you brought that up, because that is my biggest concern in terms of economic development. If the city is to grow, and which we haven't discussed, but if it does, would this be sufficient? Would option one be sufficient for that? And I'm not convinced.
If it was just Solvang, it would last you quite a while, right?
If it was
Because
just Solvang.
0.75 to 1, that's
Is that solving in its current state or solving in the future state, assuming we had some growth?
So let me just
Thanks,
try
Matt.
to address that. So the flow going to the plant right now fluctuates between about 0.7 MGD and 0.75. So if we went to 1.5, you always want to have some buffer, but that leaves a lot of room for growth. You know, now some of that capacity is San Ynez because they're not using their full 0.3. They're at like I think 0.2 or something like that. So 0.1 MGD is for their future growth, and that leaves a lot of room for Solvang's future growth. And we could even add, with the 1.5 MGD plant, we could even add Los Olivos if they decided to send their waste to Solvang. Now, that wouldn't last forever. Eventually, the area will grow. But if you based it on, you know, historical past growth, the 1.5 MGD plant, you know, could last anywhere from, 15 to 25 or 30 years. It just depends on the rate of growth, which is unpredictable based on the economy and other things.
Well, let's discuss.
We've got a
Can
lot
you
of-
define growth? Because if you're talking about residential growth, that's one issue. If
Can
you're
I-
talking about
can I
tourist
pitch
growth,
in
that's
on that?
another.
When you look at, since 1988, we have added 400 residents in
I'm not
Solvang.
talking about residents. I'm talking about tourists.
Correct. And from 1988, we averaged 250,000 tourists a year. Now we're 6 times that amount. So all this is fueled by demand of tourists. We're at 1.5 million tourists a year right now versus 250,000 back when our last sewer study was done in 1988. So it's all fueled by our
And that doesn't
visitors.
include the tourists that Chumash bring in, which is closer to 4 million per year. So that's really the kind of growth that I'm trying to get my head around. And is our plant going to support that kind of growth or even larger growth in the future?
I would say, obviously, we don't have a crystal ball. We don't know how development's going to progress. But we have a lot of with the 1.5 MGD plant. Okay, so we're at 0.75 right now. If you add 0.1 for San Ynez, that takes us to 0.85. And so when we get to about 1.2 is the time we're going to need to start planning for. So we have 0.35 MGD, and the plant's running at about 0.7 to 0.75 right now. So we have that's a huge amount of capacity. So that's why I say, it depends. I mean, if development were to run rampant, it might only be 15 years, but it'd be.
So let's
I think the bigger risk, though, in some of these options would be with regard to things that happen in politics in the future. We all know California is not going to get any less stringent on the environmental standards, and just like how we also have denitrification, new ammonia standards, all coming out.
Right.
What are the risks? You have to think about the risk in the future, not just reacting today or just thinking about growth, but what's the risk in the future of a new standard coming out, a year after you put in this new wastewater treatment plant, and all of a sudden it cannot accommodate some of these new standards. We're right back here blowing a bunch of millions of dollars again to try to deal with
And the burden
that
is always on the
situation.
cities.
And the burden's always on the city.
Well, I will mention that when you're issued a permit or your permit is officially renewed, there's usually a time period. And in our conversations with the regional board, our current permit was 10 years, and then we need to begin the conversation to renew it. So the regional board has told us that they would entertain a 15-year permit, even though our last one was 10 years. So we don't know ultimately what they're going to decide. They may stick with 10 years. But so if some new regulation comes out that's like broad, wide sweeping, you know, major, we would be given time, with a new permit, we'd be given time to implement that. They wouldn't tell you, okay, next year you gotta, like, you know.
No, and I understand all that. My concern again would be for the residents, and so you could end up in a situation where, you know, let's just say for the sake of it, you bonded out the whole entire, you know, $15 million for a new plant, and you put it on a 20-year payoff cycle, and now you're on year number 10. The state's already saying, hey, by the way, you know what? We actually want everything recycled water, whether you're going to use it or not. You know,
Right,
and
right.
now you're in a situation where you still have a debt payment on a plant that no longer meet those requirements, and now you're having to blow a bunch more money again to meet a new permit requirement 15 years later from now.
Yeah. Well, in the Central Coast region of the, you know, the Central Coast Regional Water Quality Control Board, I believe there's over 200 wastewater treatment plants, Nathan? So, yeah, and that's a lot of cities to impact financially and a lot of people. That's just the Central Coast region. So they do, you know, consider the financial impact of regulations and stuff, but you know, that is one advantage to alternative 3, is that you're going to be producing the highest quality wastewater effluent.
I have a question for you, Matt. So something that I'm not sure has been brought out. So this is the big picture. When it comes down to reusing the water, distributing to Alisol, and having Alisol not agree to limit their pumping. So has anyone taken into account our new basin management agency that's run by the federal government and the states that may well limit the amount that they can pull from wells? So although Alisol or ID1 may want to pull as much as they want to out of the ground, these new regulations could really affect that. And if that happens, I would like to see us in a situation where we're able to sell water.
Yeah. Now, are you specifically referring to the Groundwater Sustainability
GSM,
Act?
yeah.
Yeah.
Yeah, so that does specifically exclude the riparian corridor,
Okay.
the river,
All right.
the river underflow. So.
All right, so I just wanted to make sure, because that could have been a factor involved in this.
I want to return to a question I was trying to get an answer for. Andy, Matt, doesn't matter which one. If we doubled the number of tourists from 5 to 10 million, I'm not saying it's going to happen today, even 10 years from now, would this plant support that?
Okay, you said 10 million. You mean from 1.5 to 3
We're
million?
at 5 million. If you include the Chumash, which claim almost 4 million,
Well, they have their own wastewater treatment plant. So the Chumash waste does not.
but they don't all stay at the Chumash Casino, do they? They come here and spend the night in Solvang.
Right, but that's included in our tourism counts.
So if I took the extra
It
5
can't be,
million,
because if we have 1.5 million and they have 3.75 right now, where are they staying? They're not all staying at the casino, right? So they're staying here. They're adding to they're impacting our systems, and that's what I'm trying to get at.
Yeah, well, I think Mayor Toussaint was correct. Any tourist that is counted in our count of 1.5 million that's staying here, that's part of the 0.75 flow that's coming to the plant already.
Oh, that part I get. I'm talking about the Chumash. There seems to be
But Chris,
disconnect
you have to
here.
remember, you're talking about people staying here.
That's what I'm
That is
referring
in
to.
this number right here.
So-
When they flush the toilet,
No, that
it
I
goes to
got.
Solvang.
I got
So even
that.
if you doubled it, you'd have to first of all you'd have to increase the occupancy rate very significantly, or build a bunch more hotels here in Solvang, connected to our sewer pipe to feed and increase that number.
Yeah, they were talking apples and oranges here.
Yeah, it's the
So
same.
let's double the number we have from 1.5 to 3. Can
Okay.
we handle it with this?
The 1.5 MGD plant would have approximately 0.35 MGD available capacity you could give, or, you know, sell 0.1 to Los Olivos and still have 0.25 MGD capacity. So you could add a lot of hotels and a lot of houses for several years, you know,
How long?
before you're rich.
5 years, 10 years?
Chris,
Well,
I've tried to explain to you, Councilmember Dearness, I've tried to explain to you, we can't predict the rate of growth. We could look at the rate of growth that's occurred previously and project that forward, or make our best, you know, estimates, but. You
Well, the
know,
reason why I'm asking, Matt, is because I'm looking at option 1, which is 1.5 million, arguably, right? And option 3, which is 2 million. And the cost is relatively the same if we're going to go with the membrane. So which way should I go? That's the question I'm trying to answer.
So if you
Well-
double the number of tourists at 50 gallons per tourist, 1.5 million
Okay.
tourists a year, divided by 365, assuming they all come all come consistently throughout the year, which I don't think is a good assumption. That's 0.3 million gallons a day. Does that help you guys?
No, I have to write this down.
So you're at 0.75 coming into the plant now.
Yeah.
You would increase it 0.3 more,
All right, so now we're at
1.05.
right. So the 1.5 would easily cover that,
Would easily
assuming
cover
that
that,
we don't have
yeah.
a batch or a pool that goes down, right?
Right,
Because if it does go down, then that's a bigger problem. So then we're leaning toward 2 and 3.
I mean, generally, obviously we put redundancy wherever we can. Sensors, blowers, things like that. But once in a while, you have to do a scheduled maintenance on an item, and you could generally do it at night, et cetera. So the one basin out of service kind of, I don't want to overplay that. With the MBR option, we can actually run one basin and have 2 basins sitting empty. So as soon as you press that button, you convert the facility, 0.75 million gallons a day or 0.7 million gallons a day, you can run it just on the edge with one basin, right? Because I said it has 2 million gallon capacity. So if you take a third of that, that's about 0.7.
That's incredible.
It is
So
incredible, yeah. It's
That would support the long-term needs, literally for 20 years or more.
yeah, long time. But I
Okay,
don't
s-
disagree. It's, almost double the capital cost. So it's a tough decision.
But the operating costs?
Next slide.
The operating costs are also
Here it
higher.
is. Oops, look at that. Matt and I both did it at the same time. So the operating costs are actually pretty similar. And a lot of that is, this is such an efficient process. As I said, you've got one basin online, very little lab. The guys don't have to sample all 3 basins. There's less mixing energy. The percolation basin or the polishing basin cleaning, you don't have that over here. You have that over here. There's a lot of complication over here as well. So the operating cost is more here, but it's not that much different. And then if you sold it to Alisal Ranch Golf Course and picked up, 0.15, it basically makes them even.
So just a reminder, we're not asking you to select between alternatives, and we will be coming back in a month with a lot more detailed financial information. But this is just kind of
Right.
touching on it.
So if you did this black here, these guys would be running 2 basins full, 1 empty, until they picked up another, 0.25 million gallons a day. Then they'd have to fill their 3rd basin, and all of them would be full into eternity.
Well, I would only urge my council members to not put us in a situation where we are limiting our ability to implement a superior system while it's available to us to do this. And, going into a lot of the minutia as to predicted amount of individuals that might be coming to Solvang. I feel that we really should take the advice of our qualified and well-paid consultants and not limit ourselves and go with a state-of-the-art program that will give us the benefits and the opportunity to produce water that we can sell should we need to down the road.
But basically right now there is no, we're not planning on reselling this water to anyone because no one wants to buy it, correct? Is that my understanding?
Correct.
Okay.
Correct.
Well, we talked to Alisal, and they would pay, we understand that they would pay what they, incur today to pump it out of the ground.
Correct, yeah,
Which
but
could be-
the idea is you'd like to be able to resell it and actually cover some of the costs and whatnot, and really that's not feasible right now. I'm not saying it's not a bad idea for the future. I'm just saying right now we have no one out there going, yeah, we want to buy it, you know, so
That
just
is
so we know.
correct. Yeah, thank you.
Yeah, but why limit your ability to do that?
I'm
should that
not
happen?
saying to limit it. I'm just pointing the fact out that there's no one right now. And I agree in the future, like Ryan was saying, possibly the state will make people buy it. I don't know. You know, I mean, we can't tell that.
Well, I believe there already is a vehicle to kind of do that, to force them to take recycled water.
Well, in Title 22, if you bring the recycled water to their frontage, property frontage, and make it available, you can require that they take it. This is for like irrigation or uses like that, where the water is of sufficient quality to use. So for the LSL ranch, even if they're concerned about the slightly higher salt levels, their irrigation demand is twice as great as the amount of water we could provide, recycled water we could provide them, and they could blend that down in their ponds on their lake and still utilize it. So
Just for clarification, because I think the people watching at home don't necessarily get the same feel that we do or the same information we're getting. How many acre feet per year are we talking about in terms of reclamation?
1,000.
1,000 acre
1,000
feet.
acre feet a year.
And how much does the city of Solvang use per year
About
currently?
1,300.
1,400.
1,250.
It varies. Last
The
year
point I'm
was-
making is I wanted him to say that for the benefit of the people who are watching from home. But thank you.
Sorry.
Okay, I know, but if you knew the answer, then why?
It wasn't for me to say. I wanted him to say it so that the people at home.
All right,
could
let's keep
understand.
moving.
But this is important because.
Okay, so basically at the end of the day, you know, are we going to do recycle water? Yes or no? If we decide we never want to open the door to recycle water again, the operators would love to operate option 2, which is clarifiers, which we haven't talked much about today. If you add on a couple clarifiers, you could get to a big capacity. It has the lowest operations costs. But if you ever want to do recycle water, it's just pretty much hands down the way to go is going to be option 3. Now, the hybrid of this is you could do option 1A now and defer it till later and convert it to option 3 later. There will be an extra capital cost. So if I go back here, it's not like it's 8 million plus 7 million gets to 15. There's going to be an inefficiency here to do 2 projects
Yeah.
and throw away some things. So that's pretty much it in a nutshell. Here's kind of the flows that we started with, how we got to 1.5 and how we got to 2. I could go over this if you'd like to, but I think we should just continue to have discussion, and then I think you want to vote on a couple of those items, Matt.
Yeah, so that concludes Andy's presentation, but so I know we've been answering some questions along the way, but any other questions we're happy to answer.
Is there anything that you have a bunch of staff members here? Is there anything they'd like to contribute that would be something that we could take to what's been presented? Any ideas, any thoughts, anything that hasn't been said?
If Paul or Nathan want to say something about it?
You don't have to. I just.
I don't have a whole lot to add. The only thing is, depending on the brand of equipment used, if something were to break and we didn't have like an extra pump for one basin to be down, it would be more like several months down, not a couple weeks. But most of the time we have extra parts in the shop for that purpose. But I don't want you to think that, you know, if there was one that went down, it may not be right away that we could put it back on. But if the plant was already at that capacity, we could run it on 2 anyway, so it would be all right. That's all I had to say.
Which would you prefer to operate?
Well, recycled water is the way of the future, so the MBR's going to be the best one. It's a lot easier to operate in some sense because it filters the water, so you don't have to worry about settling. The clarifiers system is a simpler system, and it's been around since the beginning of wastewater almost, but it's not going to get you the cleanest water unless you add all the other stuff at the end. So then it would actually make it more complicated. So the MBR is probably the way to go.
And then can I ask, what's your opinion of if we were to do that option 1A that allows us to defer to option 3 down the road? Do you have any opinion on that?
If we were, I mean, you'd probably want to make sure that you want to do recycled water in the future. You're just wasting money then if you do that and then convert to that later. It would.
Well, you're saving money now, but you're yeah.
Yeah,
Putting it off.
but there was, you know, you could, like you were saying, finance get that nearly paid for and then redo it again, and then the impact of rates all at once would be not as bad as doing the MBRs from the beginning.
Mm-hmm. Yeah.
So.
Thanks.
Thank you.
I did want to mention, I failed to introduce Jeff Hodge. He's the general manager from the San Ynez Community Services District. He's here. We've invited him and his board, and I don't know if he wants to add anything, but.
Thank you. Yes, I would love to with that. First off, thank you. Yes, Jeff Hodge, the general manager for the San Ynez Community Service District, and company this evening with my president, Ms. Jones. But yes, currently, if you're not aware, we operate as we're the contract operator for the Shoemake facility, which is a BNR. That's the biological nutrient removal side of things with the MBR at the end. So to start there, so much of our discussion today has been by the hydraulics of this. You know, there's also the organic component back there, which is right now taking the ammonia coming in, and we all hopefully know where the ammonia comes from, and converting that into biomass, and then with the BNR process, we're letting it off as nitrogen gas. At the Shoemake facility, we're being pushed towards the phosphorus limit, which you're not seeing here, but would undoubtedly come. So as we stand, you know, I see that's good money spent on the MBR with the BNR process up front. And thank you for asking me to come up, because having some experience with your water side of things, not getting into details, just implore you to begin utilizing that and recapturing in whatever form you can. But that's between you and your water lawyers and engineers. But that's a huge valuable asset. I performed one similar, and it was a $10 million part of the equation. So I continue to. That's not our part of the wastewater side of things, but it's a huge value to this. And back to the operations of it, you have all that under aeration. You have a lot of flexibility. And back to 23 years, stand before you today. It was 23 years ago today that I started in this business. Tax day, so it's easy to remember. So I've been very fortunate to run everything from ponds to oxidation ditches, extended air, now the MBR. So the whole broad spectrum of this, and love the flexibility that the MBR provides. And back to your question, I mean, we get into the numbers with the state, but I will happily any day take an overloaded plant versus an underloaded plant. You know, it's kind of like the starvation thing. I think we all rather have a buffet than one French fry from McDonald's to make it through the day. Treatment plant. You got to do the food. It's what's processing it. And hence the beautiful thing about wastewater. It's a living, breathing organism. But with this, that part is back to what Nathan was saying. We don't have to train the bugs to settle. You know, and back to the nature of what we see coming in here is the fats and oils and grease. They can form some critters that don't like to settle, which the clarifier, they could come over the top, you know, as you see today. So very supportive of the MBR. I realize that there's a little more money up front, but I think once again, if you're aware that, you know, your staff is moving forward with hopefully acquiring some of the integrated regional water management monies, you know, so there's other monies out there.
Well, one of the things that was brought out by Andy earlier is that number one, option one is $1.5 million, and option two is $2 million. Why do we need a 2 million plant? 2 million gallons per day plant?
I think the thing is that I always batch these and things. Once you're under 5 MGD, you know, million gallons a day, you're in the small plant category, and now we're down in these basins that are the size of this room. You know, so 2 or 3 extra foot this way and 5 foot in a wall, all of a sudden you've picked up that capacity.
So you're saying the extra capacity is worth
you have the extra capacity built in.
Enough said.
Yeah.
So that would pull me more in that direction. The second thing, since you appear well qualified to answer this, is what new technologies are out there in the future that would change the direction or make us want to regret going in this direction? So, for example, this is the state-of-the-art technology today. 5 years down the road, something else comes out, maybe 10, as Ryan was explaining. Now we're looking at a new investment, for example?
Well, I think the front part of the plant's going to stay the same in what it can do with the nutrient removal, be it the ammonia converted to the nitrogen gas and let off, and the other part, the phosphorus. The end one, yeah, those life cycles are going to not be the same as the 40-year life cycle for everything. Once again, we were really fortunate working with, actually it was with Pace and Perk on the Shoemash facility, design build. We basically kind of, project managed that for the owner. And with that, we're able to go with a much less costly membrane. A Korean manufacturer took that gamble because we had that ability to do that, and it's worked out fine. So, it was probably half the cost, and it's good to have that longevity. But the short of your answer is there's always going to be something else that comes down the line. But back to what Matt's saying, 10 or 15 years in that permit, it's going to take you way out there and then some. So you shouldn't have those regrets. We're on the fourth or fifth, maybe even more generations of the membranes.
Well, the reason why I ask is if we have to go to a bond issue, that's going to essentially cover the same lifespan as a plant, right?
Correct, but in your day-to-day operating budget, there will be, and I'll let the engineers get in that part of it, but the membranes, they're a fiberglass thing, so there's grit, hence you want the grit taken out up front. So there's going to be some wear and tear and some replacement with those, but it's not going to be the full replacement. It's like replacing a motor.
As technology evolves, really it's just the back end that I'm hearing correctly that needs to be updated or upgraded.
Right.
And that's not a significant, well, it is a significant cost, but not like changing out the entire plant.
Correct.
The front 2/3 basically stays the same?
Yes, you're going to get your ammonia, your nitrogen side of things, and in your phosphorus if that permit comes along. I just throw that out, that on the federal side that we deal with, the Shoemash, we see that coming.
I'm looking at this in terms of components, right? And
Yeah.
If I could help out a little bit, if you don't mind.
No, please.
So two things that I think Jeff said that were really important. If you want me to use the mic, I can. But
No, I hear you.
Jeff said two things that were really important. Number one, the phosphorus thing. Phosphorus makes algae grow like crazy, and it kind of contaminates downstream discharges. And as you said, in Chumash, we work together. They're looking at having to remove phosphorus. The only way to remove phosphorus, unfortunately, is to have a filter. So that means you have to do purple, purple, or purple. So not to say that we have to put it in now, but at some point, if you do have to do phosphorus and protect the San Ynez River underflow, you're going to have to put in that system. The second thing that you talked about was, clarification. So I just wanted to make the crystal clear what Jeff was saying there. On this process and this process, you have to take the bugs that ate the stuff that you can't see, and you have to settle them down to the bottom, or else they'll overflow into the polishing ponds. With the membrane, you don't have to do that, so it protects the polishing ponds. And the operators obviously struggle sometimes with settling these bugs that sometimes want to float with grease. So those are the 2 points that I kind of wanted to make. They're kind of intangibles. Go ahead, Matt.
Andy, also, if you could just briefly touch on the life cycle of the membranes themselves relative to the overall project, just so
Sure.
it's clear to the
Yeah, I mean, I think Jeff made another good point about the membranes, is that they become a commodity. For the benefit of us and the detriment to the membrane manufacturers, they compete and compete and compete, and the costs have come way down. So, we do these projects. If I go back to that one slide about where the money is, the money of the membranes might be 5% of the project. And when you replace these membranes, they last 8, 9, 10 years. When you replace them, it's really not that much of your OPEX budget. That OPEX budget that I showed you, it included replacement.
Yeah, that's what I wanted to get at.
Is it possible for that OPEX to come down over time?
Yeah, I mean, it's amazing how inexpensive.
That's
these
what
are.
I'm hearing from you.
I'm doing a project in Portland that's $200 million, and the membranes are only $7 million. You look at the 3.5%,
Right.
it's amazing.
So of the 1.5 million, I guess, is that what it was going to cost us per year to operate, roughly speaking?
Yeah,
1.5 million?
1.4.
Over time, with newer and better technologies in terms of membranes, would that come down, or would that basically stay flat?
Well, it won't go up as much because, power and chemicals and all these other things are going to increase over time. But the cost to replace the membranes, just kind of like computers, how you pay the same amount today for a much more powerful computer than you could get, even like 15
Yeah, I
years
appreciate
ago.
the processing and all that. It's much more powerful.
So the technology is advancing and the competition is really good out there on the membranes. So the replacement cost for the membranes won't go up as high as, it won't track the consumer price index or whatever, because
If I could add one more thing, As if you're asking for what my opinion is, I think it's a tough decision. Obviously, I think you can kind of hear if you read between the lines. I think kind of the membrane would be the ideal world from an engineer standpoint. But the other crystal ball thing, somebody kind of asked what else could come down the pipeline, but you might have to disinfect this water. At some point, you're not disinfecting all of these pathogens that go into the underflow of the river. So to disinfect, you almost have to filter. So once again, you're leaning towards these purple bars again. And in this option, it's not easy to do the downstream process. So Chris, you're kind of jogging my memory and making me think of things. The downstream side of the process is not the same. In the clarifiers or the membrane, a drop of water in is a drop of water out. But with the SBR, you're holding the water, holding the water, holding the water. All of a sudden, you're releasing a whole bunch of water. Now you got to build a big concrete tank to hold that water and then release it into your downstream process. So it's a little harder to convert from here to here.
Yeah, I don't have a problem with full recycled water. I'm just trying to justify it. And I'm sure we're all struggling with this because what you're telling us is
a lot of
the demand
intangibles.
is not really there yet. But 5 years from now, it could be a different world because state regulations will change and make it possible to filter. And then we'll have to go with the MBR model so we can go ahead and purify the water and use it for potable purposes. And it has the upside of being less expensive to operate, right? Easier to operate, as Nathan and you guys were explaining earlier. So I mean, I really want to do this, and I'm really close to this. I'm just trying to figure out, okay, should we go with number 1, 1A, or 1B, whichever one that was called, or do we go with the full MBR?
And maybe once we proceed, I just want to say maybe there's an option 4, which is, Matt, we could look at this black bar converted to this purple bar and see what that number looks like. So a piece that's up to here and then plus to get to here. So.
And just to clarify, we've kind of touched on this, but the basins right now, those SBR basins, they're adequate in size for 2 MGD membrane plant.
Right.
But we could build the plant, if we went with the membrane plant, we could install membranes only for 1.5 MGD, and then when needed, add that last membrane to bring us up to 2.0. But as shown in the cost, that incremental cost is really small for the alternative 3, the membrane alternative, because the basins are all there, everything's all set up, you got the membranes for 1.5, you reach that, you add the other membrane, and now you're at 2.0.
Yeah, Matt, if I could interject, I mean, you could actually put in this facility and put in 1 or 0.8 million gallons a day of membranes. You can always add membranes. I mean, it doesn't trim a lot off, but it would trim a little bit off this bar.
Right.
That's a
Whereas
good point.
the other alternatives, if you drop from 2.0 down to 1.5, there's significant cost savings. And of course, the existing SBR's alternative 1, the basins are adequate for only 1.5 MGD. So if we wanted to go to 2, we'd have to build a whole new basin, and that's the big cost. All that reinforced concrete and excavation and all that, labor and everything. So that's like a big cost item if you wanted to do that.
And of course, none of this all, purchasing the 2.3 acres is on top of these costs. I'm sorry, I don't know this correctly.
Yeah, I'm glad you brought that up. Yeah, so in addition, so these are construction costs. I don't think did this include the engineering and all that? I don't think they.
It did. Soft costs it included, yes.
Okay, so.
But I don't know about the land. I don't
But
think
it doesn't,
yeah.
yeah, so, well, actually, it did include,
land cost, okay.
include the,
No, I don't think
for alternative.
they haven't arrived at a number on the price of the land. We just know that
Yeah, there was no number in there for the land.
Correct.
all 3 options are going to require the purchase of the 2.23 acres.
No, not the 2.3. We have there's one option, I think is a 0.6
Yeah,
acre.
alternative 1 and alternative 3 only require 0.63 acres. Alternative 2 with the new clarifier basins, since they're so big, those would require the 2.23. But staff is recommending that whatever alternative we go with, we go ahead now for a variety of reasons. We have a willing seller, and that might not be the case for very long or forever, we don't know. And Then if we wanted to implement solar with this project, we have the extra land to do that. And there was one other reason, it's escaping my mind right now. But,
Actually, you bring up a
so
really
we're
important point,
recommending going with the 2.23.
which unit or which design uses the least amount of energy, or which is the most energy efficient? Because I understand that's a big cost of operation.
Well, it depends if you're black bars or purple bars, but generally this is the least electricity.
The clarifier model.
It is. But the electricity is just not a small, but it's, 15 or 20% of the overall OpEx.
But that's why in my head, when I'm thinking of how this converts to people's water and sewer rates, to me, the only decision is between option number 2, black bar, because of the lower capital cost that's going to eventually turn into a loan, and other things are going to have to be financed through our water rates, or you're going to take it to the next step and you're going to go for the bigger MBR plant, which is going to come with a higher capital cost and a little bit higher operational cost. But at the end of the day, when you factor that into your water rates, that's going to significantly increase the operational revenue we'll need coming in on a yearly basis, which will have an impact on people's rates. We'll go to public comment a little bit, right? And that's just still questions of staff.
Okay. And I was going to mention, we did just receive the appraisal. We haven't had a chance to go through it completely. But of course, real property conversations are appropriate for a closed session.
Yes.
Yeah.
Thanks, Matt.
And can we, how expensive would it be to put solar energy, use solar energy to go ahead and operate this? How much of a savings would that be?
Yeah, we haven't evaluated that. I'm sorry.
Much on 1 point some odd acres of solar panels. We went through that up at PG&E at the power plants. We discussed that.
Yeah. But yeah, we haven't done that analysis yet. Yeah.
Are you going to do that?
Well, it depends if the city council directs us that they want to move towards solar, and we can do it.
Well, the reason why I asked, I had discussions with some guys up in Sacramento back in January, and they had suggested that they might be able to find ways to save the city a substantial amount of money in terms of energy. And one of them was perhaps the way we produce energy for our wastewater treatment facility. Perhaps we'll go back and look at that.
Yeah. Well, I will mention in our pre-application, the staff had to make some assumptions, and so we hope it doesn't upset you too much. But we had to present a specific project, and without the benefit of well, just basically because of scheduling and everything, we had to proceed with that without the benefit of final direction from the city council. But in that,
Are you talking about the grant
yeah,
grants?
the grant pre-application. Yeah, this is for the
Which I think is another significant part of this conversation, because I think there's a lot more grant opportunities around the MBR plant, which could
Right,
even negate some of the.
Right. Yeah, there's a whole huge grant potential if you do implement the MBRs and produce recycled water. But as far as the integrated regional water management grant program, the pre-application, we identified alternative 3 and implementing solar on the roof of the new office and lab building. So
We've done solar on wastewater treatment plants about maybe a half dozen times, and I could share with you guys our most recent one, which is in Bisbee. The return on investment, it's long-term, depending on what you get for grants and credits. But
yeah, I was going to mention, so of all the applications received by the county for this first funding cycle in the Integrated Regional Water Management Grant Program, our application received the highest score. So it's looking good.
And that's, just to clarify, that's the one in the staff report that's talking about, I think, $1 million potential grant that could potentially come to another
Correct.
million
Yeah,
the
they
next
have-
year or something.
Yeah, that's correct. So they have 2 funding cycles in this grant program, and the second cycle will be in about 1.5 years, and presumably by that point we'll have the plans completed, we'll have the land acquired, and our environmental work completed, and so we'll be in a really good position just to request for the additional funding, especially because of, no matter what we do, it's going to be far more than $2 million. And so the city's share, matching share of the cost will be really high. And so yeah, we'll be in a good position to.
And are there any contributing, primary factors they're looking for that, in their rating system? Are we aware of what it is that ranks the highest, such as a regional plant versus, or
Yes, that's a really good question. So, of course, sustainability and minimizing environmental impact and everything is some of the criteria. If you have a project with multiple beneficiaries or multiple agencies participating, and since our plant does serve the community of San Ynez, that helped us score really well. But yeah, they do have a whole list. It's about 10 different primary criteria. And so when we wrote up the pre-application, we focused on trying to emphasize or highlight those aspects of our project that met those different criteria, and that helped us score really well. So.
I think my only last question was going back to when you were showing us some of the depictions of the different plant options. It seemed like the MBR plant was like the most simple plant in terms of less sections or
Yeah, there she is. I mean, all we have to do, there's not the big box here, there's not the big tanks here. You just basically put a lot more bugs in one rectangle. And this one's empty and this one's empty until you get some more flow. And then this obviously fills up next. And then you probably never have to fill up the third, but you could. And then you've got these little tiny squares here. And these squares have membranes. So 1, 2, 3, 4. And those membranes will each have about 500,000 gallons a day piece. So a half plus a half plus a half plus a half. And then all the equipment goes in here, comes out really high quality water. You could either put it in the percolation basin or you could use this existing tank and send it up to LSL. So it is very simple. And I'd say, probably 3/4 of the plants that we design now ultimately end up with this type of process.
Of all the cities in California, I mean, how many have this system compared to the older systems? Do you know roughly or percentage-wise or anything?
I'm a little confused by your question. Like most of the plants that get implemented now are the membrane, but if you look overall at what they have, it's still a very good mix.
conventional, right?
Yeah.
So most of them don't have this existing right now. They don't have the MBR system. Most of the cities.
Yeah, I'd say 2/3 probably don't, but it's quickly, the 1/3 of membranes is going to become 1/2,
Right.
and then someday it'll become 2/3. And I would say that the SBR is perfectly situated to expand to an MBR. And in fact, we've done that 3 times now, where we've taken an SBR. I'm doing it up in Mountain House, California right now. An SBR converts to an MBR very, very simply. You build on this little box, and you're home free.
So is anyone stuck with the SBR and not converted to the MBR? Or are most of them like they're just planning on going to the MBR? They're just doing it for cost purposes, basically.
Yeah, I mean, we could have, added a 4th basin here, but that makes it, more complicated. And I hope I answered your question.
I think maybe to your question, Councilmember Johnson, I don't think anybody's building SBR plants anymore, are they really? Not much.
Some people have that operational preference, yeah, but not very often.
Yeah.
Yeah.
Okay.
So what I did is I used your estimates here on page 15 regarding capital costs and operating costs, and I used 20 years for operating costs. And I combined the two. Basically, for example, 1A would be about roughly $8 million. It's a little less. $8 million for CapEx, and then 20 years times 1.4 million. And I ended up with $36 million over 20 years, right? And I did that for each of your alternatives. And ironically enough, number 3 comes out the cheapest with $35 million over 20 years, if I did the math right. So I'd like you to check my math.
I think we did that same life cycle analysis in the report, but it doesn't seem like
Yeah,
off
so
the
remember
top
in
of
the
my
in the
head that
report there
makes
was a
sense.
longer.
And again, this is for the purposes of people watching on
Sure.
TV.
So option 3 had a higher CapEx, and it actually has a higher OpEx. So I don't know how it's going to be higher life cycle.
Okay, I guess I was looking at 1.5 million gallons, not, and even if it is 2 million, it's not, oh, that's even better. If you go with the 1.5 million for option 3, that would be cheaper, even more, less expensive.
I apologize. I'm a little lost. Can you
produce that report? I mean, that.
Sure, you got it here.
Why don't we, if there's no more questions, why don't we go to public comment?
Okay.
But if you give me that binder, I think I know what page it is. I can easily find that and give it to Chris. All right, so with that, are there any other questions of staff from the council? Okay, that will go to public comment. Karen Jones.
Liking that flattering lighting. I'm Karen Jones. I'm the president of the SYCSD board. Thank you for telling me about this meeting. I'm glad to be here. My biggest concern, well, first I'll say absolutely for the membrane system. If we can afford anything, obviously that's going to give the most bang for the buck, be the best situated for future needs. But I am very grateful that your council is also considering how much it's going to cost each person that receives the service, not just the people that are in the tourist business, but the people that are homes, because most of Santa Ynez is single-family residents, and so cost does matter to us. So that is something that needs to be considered. But everyone that I have talked to that has knowledge of how these systems work prefer the membrane because it does put us in a better position in the long run. But I look at this and I think it reminds me of when I'm buying a car. If I'm going to get a nice solid used car with under 100,000 miles on it, or if I'm going to get a new Ford, or if I'm going to go for the new Mercedes, which, you know, I'm not going to get. But a lot of people can afford to make that choice. So I would like you to just continue to factor in the cost to everybody, not just the potential business benefit, but also to the homeowners and residents. Thank you.
Jeff, would you like to speak?
Yeah, pretty much covered before. Thank you.
Okay. So with that, we'll bring it back to the council for discussion and action. Daniel, would you like to start?
I think basically the MBR system obviously is the one you want to go with, except for it's just, I mean, that capital cost just looks drastic. It would be a lot nicer if there was possible ways of selling the reusable water. I think that's the big thing when I looked into this before, was being able to sell it and offset some of those costs, and that just doesn't seem feasible now. I do think the state's going to come down with more regulation. I don't think they're going to have less regulation, so I think we got a plan for that going forward. So I think the next action would be how we plan on paying for this, where we plan on coming up with the money, and how much we're going to increase to the residents and the businesses, how much they'd have to pay. So that's just something we got to think about and talk about.
Okay. I believe I just found that page. So I don't know if you want to just explain this to Chris really quick before his comments.
So if you do get a copy of the report, page 7-6 shows the life cycle cost. So it's the capital cost plus the present value of 20 years of OPEX. And I think you found the one for 1.5 million gallons per day. But it basically shows you that the life cycle cost over 20 years for option 1A is $28.4 million. And the life cycle cost for the MBR is $37.2 million. Now remember, this is a master plan, so we would update this as we move forward, but it is a delta of about $9 million over 20 years. Any questions?
Okay, so my math was a little bit wrong, and I agree. If we were able to reclaim 1,000 acre-feet of water, right? This is back of the napkin type of stuff. If the delta, the change, is basically $7 to $10 million over 20 years, and we were able to save or reclaim 20,000 acre-feet, right? 1,000 acre-feet per year.
Yes.
So it's basically, we'll use worst-case scenario, $10 million divided by 20,000. That ends up being about 500 acre-feet per year. $500 per acre foot. Again, back of the napkin.
If you could sell it what everybody else sells it for at 500, I agree with your math. If we sell it to Alisal for, what's to say, $150 an acre foot, we'd pick up $3 million. So it would close that gap from, what did I say, $7 or $8 million down to $4 million, plus or minus.
So in the short run, it would help offset some of that loss.
It would. Now, what it
And
does
then-
to the, underflow volume in the Santa Ynez River, we would also have to think about, but this is an option for us.
But essentially, we can't get to that underflow because our wells would be above where it's going, correct?
Well, I think also if you were delivering out to a customer like Alisal, you're not necessarily taking the recycled water to toilet to tap type per se. You're just actually bringing it to the point where you could actually use it for a golf course. Is that
Yeah, just for irrigation.
so? Then we wouldn't necessarily have to, in that scenario, run it downstream, pick it up later, and go through that whole.
Correct, yeah.
And then also, if you were just to produce recycled water, you're not going to have to take that extra step to meet whatever California standard comes out tomorrow to actually be able to directly reuse it into our normal infrastructure.
Correct, that is
So
correct.
just to, I kind of agree with what you guys have said. It depends on the travel time. So if there's, a year or 12 months worth of travel time, there's a chance that you're done at that purple bar. But if there's only 6 months or something like that, you might have to add another step on top of that bar. Is that
Even for
clarify?
use at a golf course, for example.
No, I'm sorry. I'm sorry for being confusing. I'm saying if we do ultimately decide we want to take it out of the ground downstream someday, the level of treatment's going to be dependent on how long it stays in the ground. That's all I'm saying.
Got it.
Does that help clarify? But if you go to the golf course, that purple
And
bar
I think I was
is
just
it.
trying to explain it so everyone understands. There's basically two different steps or levels of recycled water we could produce. One would require less filtration, less treatment that could be used for a place like the golf course, like what Daniel was referring to. But if you do ultimately want to do toilet to tap, then you're talking about a whole nother requirement and a lot more cost for us to be able to perform that function.
Yep,
Is that
correct.
That's accurate if you went direct potable reuse.
Yeah,
But if you, is that what you guys are saying?
Yeah, I think
Okay,
that's what
thank
we're
you.
trying, yeah.
How far would
or,
it have
or,
to
wh-
travel?
or whatever the basic 3 or 4 options we have, just so they understand the difference between these different functions and what would be
Sure. I mean,
entailed.
it's a developing field.
Yeah.
It's amazing when you go to these things, these conferences, and see what people are doing every year. It changes so much. But someday, they will be direct connections, someday soon, direct connections out of the back of a plant. San Diego's the closest that there is. It's 10 days of retention time in a reservoir. But generally speaking, the longer it stays in the ground, the less you have to treat it at the facility.
Perfect.
How far does the water have to travel in a year? Like a mile, 10 miles?
Depends if
20?
it's sand or gravel, or it's just, you have to do a tracer test. You see how far or how long it takes to travel from X to Y.
And how fast is it moving?
And you're talking all inclusive, including the time it takes to get through the percolation ponds.
Exactly.
Yeah.
Yes.
So, does that help?
Well, actually, generically speaking, would we be able to recapture any of that water within our city limits, so to speak? Because it sounds to me
It would take a
longer.
hydrogeologist to take a look at that for
It
us.
just intuitively seems like it would take a lot longer.
Yeah, we may be in a situation where the distance downstream that we'd have to place the wells is too far down.
That's what I'm trying to say.
Practical.
Exactly.
Yeah, so, and yeah, Mayor Toussaint mentioned that at the beginning also, but,
That's why I personally don't place any bets on those
Right,
type- 'cause
right. It's-
between the
you know.
feasibility of that plus all
Yeah.
the infrastructure costs and everything that you'd need to pick it up later on and then pump it back to the city, it just seems very
Yeah,
intensive.
so you both make really good point that may not really be feasible.
Okay. Robert?
I was stressing for a week about $31,000 for a Christmas tree, and now I'm looking at $15 million.
Your microphone.
If you look at the grants, you look at selling water, the long-term costs, as Chris brought up, it's all very attractive. A bond issue would obviously be the only way to go. My biggest concern is not raising anybody's rates and finding out how to do something like this without that. I mean, the reason we need more capacity is because we have so many more visitors. Do you move some of that over to that burden to To our visitors, these are all things that I need to think about. But obviously, from what I've watched today, it sure seems like the MBR is the way to go. And then just how do we pay for it? Done.
Okay, Karen?
The MBR is definitely the way to go. I am very sensitive about pushing costs out to our users, increasing costs. But we are looking at a very necessary improvement that will improve the lives of our residents, the quality of lives of our residents. And, you know, I can't say, you know, nothing's for free. You can't make a major improvement like this that is much needed and should have been done a very long time ago without having to push some costs to the residents. So that's the bottom line. That's how I feel.
So I do very much, I lean towards basically the same situation as last year, which is to me it just seems obvious between option number 2 and 3, a much higher cost. But I, for many reasons, lean towards the MBR plant. My concern is just costs and how we're going to logistically figure that all out so that it doesn't create some huge burden on the residents that live here. But it just seems like between all the different things we're talking about, especially with potentials around receiving grants that could make up some very, when we really looked like that total operational cost earlier, I think a $9 or $10 million gap, you know, it seems to me like the only way one way of closing that in is pursuing just use of that water, you know, selling it to Alisol to kind of close on that gap a little bit. But then a mixture of that and hopefully receiving some grants, we might be down to the same cost anyway, and in a much more secure position, not only with regard to capacity, but also even just different standards that could come out tomorrow. Like we're even talking about phosphorus. I think you were saying the only way to filter that out or to get that out is through a filter. Well, the only way you're really going to get that, from my understanding of this presentation here, is going to be all of the purple options there. So to me, it almost seems like, you know, the most secure decision in the future is moving down the MBR way. What I would really like to see moving forward, though, is just some more serious discussions or workshopping around how we can do this in a way that the burden does not impact the residents so much. And that's really what my focus is. I think we can do this. This is it'll be a fun process, but that's where my focus is going to be, is really on making sure that we don't have just massive unjust costs in the water rates and things like that. But aside from that, I did like some of the forward thinking in the staff report, especially around, you know, possibly acquiring more land while it is available for sale. Of course, I have no clue what that cost might be, so we'll have that later on in closed session meetings and figure out what could potentially be done there. I really like any ideas of whatever we can do to be more green and solar panels and what, you know, hopefully as long as it has a payback, then, you know, it might not be for all of it, but if it can do a chunk of it, then I'm all for it. So I think right now tonight we're looking for direction on two
I'd
options.
like to make my statement. Thank you.
Well, I thought you spoke earlier, so that's why I was moving on. But do you have anything else, Chris?
Yeah, I do want to make a good point. One further point, and I want to piggyback on what Robert was suggesting, and that is to look at the possibility of creating new revenue streams that would help offset the cost of this. I'd also like to know what the cost of a bond issue would be. I mean, obviously it depends on how much we're going to borrow, and that would also suggest that we look into wrapping up other infrastructure projects into that same bond issue. But I think, intuitively, that if we increase the number of boutique hotels where the average occupancy is well over 80%, I'm thinking of a few of them, and I'm sure you guys can think of them too, but they're in the 80 to 90% per year typically, and they're charging anywhere from $300 to $1,000 per room per night. And those kinds of hotels will generate a lot more TOT, which then could be used to pay not only for this, but also to reduce the cost of the water rates to our residents, which I think was the original intent of the TOT. So those are things that I would like to see the staff study and get back to us in terms of the council. I think that would help us make that decision more easily.
And all that can be attained in a simple forecast model. We can take into comparison some of the options here: operational cost of an MBR plant, capital cost, bonding issue, interest rate. All that can be considered in there. Any potential deal with Alisol to help offset the gap, such as the $150 per acre foot. If we're already going to be producing recycled water anyway, then hopefully we can find a buyer that's even buying it at the rate that that they would otherwise have to pay to pull it out of their own well. But I think that would really bring a lot more clarity and everything.
One other thing, Ryan, too, is also to work into the cost is possibly talking to Los Olivos. I know they said they're not interested, but if it could be a lot cheaper for them to go this route, you could say, hey, you're going to spend $5 million or you're going to spend $4 million with us. They may consider it. They may be more apt to look at that.
So I'm sorry if I didn't make it or mention this, but the reason why they indicated to me that they were really looking more at their own small sewer collection system and treatment plant is because they felt at this point the cost can be a lot less for them. So yeah, so I'm sorry if I missed mentioning that.
But we are open to it. I think that's really all the more parties you can have involved in paying this, such as just even having, saying as CSD, having 20% partnership in us, that's going to significantly help us in this kind of scenario today. So
I just wanted to respond.
In terms of the overall financing package, that's why we split these conversations up, so that today was really talking more about the nuts and bolts. Here's what the plant is, here's what our issues are, here's the options before you. And when we come back at the end of next month, we'll have a robust discussion, and we'll be looking at lots of different options on the financial side. And I'm hearing loud and clear that as well as any place we can potentially create a revenue stream through water, which who knows where that may be. If hopefully, so we'll look.
I think we're all on the same page. I think that now you know what we're really looking for, which is to beat you up around a calculator for a bit.
Yeah. Get out the Excel spreadsheet.
Exactly. So, Matt, would you like to re-summarize what it is that you're looking for us tonight?
Sure, absolutely. So we're asking the city council's approval to proceed based on a project capacity of 1.5 million gallons per day capacity for the plant. And then we're asking for your approval to proceed with the land acquisition of approximately 2.23 acres.
Okay. Do we have any motion?
I will make a motion to approve the wastewater treatment plant project capacity to 1.5 million gallons per day. Additionally, directing staff to proceed with land acquisition of 2.23 acres. We don't know the dollar amount, so are we putting a... Nope. It's okay, got to come back.
Yeah,
all right, then that is my motion. There's two items.
And I'll second that.
It's been seconded. Can we get a...
Councilmember Clark?
Yes.
Wait.
Yes.
Dearness?
I'd like to amend that motion and ask staff to...
Is your microphone on, Chris?
I would like to amend the motion and ask staff to consider the option of going to 2 million. What's the marginal cost? So I want to look at both 1.5 and 2.
I think in the costing calculator for that, it's very easy just to add that in there.
Yes, we can do that.
Yeah.
Perfect, thank you. Then I say yes.
Okay. As amended?
Johnson?
Yes.
Mayor Toussaint?
Yes.
Councilmember Wait?
Yes.
Passes 5-0. And with that, we're adjourned.
Thank you very much.
Andy, this is yours, I think, get part of that.